Hi, let's take a look at 12.5. First, we're going to skip the first page and dive right in here on the second page. So, note, this is a nice bell-shaped distribution with discrete data, whole numbers. But if we look at it with continuous data, a nice curve like this would emerge for many situations. They call this the normal curve. The normal curve and empirical rule. So here's your normal curve. This is right in the center you put your mean. And then you're going to be moving across this axis here, adding standard deviations or subtracting standard deviations. Then each region is corresponding to a certain percent area under the curve. Okay, so consider the IQ test. The test scores have normally distributed, or have a normal distribution. The mean is 100, the standard deviation is 15. Draw and label the IQ normal curve. Okay, so we can go ahead and we're trying to reproduce this picture here as best we can. Okay, something like that. And then right in the center, this would be our mean, and they said that's 100. And then we'd have plus 15, and then 100 minus 15, then plus 15, then minus 15. So this is one standard deviation, two standard deviations, and then down here we'd have three standard deviations. So 145. Down here we'd have three standard deviations, 55. So then I like to go ahead and write in the percents. Okay, so we have this nice normal curve that we're going to use to help answer these questions now. So we want to know what percent of the population of adults have IQ scores between 85 and 115. So 85 is here and 115 is here. So I add up these two regions, the 2%. So 34 plus 34 is 68%. Between 70 and 130, now I have 13.5 plus 34 plus 34 plus 13.5. So that's 95%. Between 55 and 145, we can add up to 35, 13.5, 34, 34. Alright, excellent. So this is the basic idea here with this normal curve, that we can use it to predict these percents. Here's another picture. If a data set is normally distributed, then we can use this empirical rule that certain percents are between different standard deviations. So it says use the empirical rule and drawing from the previous page to determine the percentage of people who have IQ scores between 100 and 130. So we're going to go back over here. So 100 and 130 looks like 34 plus 13.5. Okay, let's give you a couple minutes, give these a try. Alright, let's check our answers. Okay, if you're having a hard time, please reach out to me, reach out to Devin, we can get this cleared up for you. Number 8 says, in a random sample of 700 adults, what is the expected number of people who have an IQ within 1 standard deviation of the mean? So if we look back at this picture up here, within 1 standard deviation is 68%. So we need to take 68% of 700. So we'd expect 476 people to have an IQ within 1 standard deviation of the mean. And so if we had 700 adults, how about within 2 standard deviations? So if we look up here, within 2 standard deviations is 95%. So 95% of 700 is 665 people. Alright, the next page, I want you to go ahead, draw your nice normal curve, and then use your drawing to answer these questions. Okay, so take a couple minutes, draw your normal curve. Alright, so here's our nice normal curve about getting relief from this pain reliever. We're going to use this now in the following questions. So take a moment, answer those questions, then come back and check in. Alright, so check your answers. Hopefully you're getting something like that again. If you're not, please ask me. Okay, number 11, same kind of idea. We're going to go ahead and draw a normal curve. We're going to use that to answer questions. So take the next minute or two, do your normal curve and answer the questions, then come back and check. Alright, let's check in on our answers here. So for part B, we have 34 plus 50. It's because we're looking for child care that charges more than 12,500. So this direction here. So the 50 is this half of the normal curve, because the whole curve is 1. So 100, so 50% here, 100% for the whole curve. Okay, yeah, check them out. Let me know if you have questions. Okay, 12 is very similar, so take a minute or two, draw your normal curve, answer the questions. Then come back and check. Okay, go ahead and check your answers. The challenge problem asks us how many students would have to be in your math class in order for this percent of the class to be a whole number greater than 0. So we need to move that decimal point over, and we could do that by multiplying by 2,000. Okay, next one, same idea. Take a minute or two, draw your normal curve, then come back and check your answers. Great, go ahead and check your answers. Notice F and G were repeats, so you don't have to do that twice. Okay, this is as far as we're going with the normal curve. If you choose to take a statistics class in the future, you'll be doing a lot more with that. I hope this helps.